Good morning students. Today I am going to discuss about functions. What is a function? What is the definition of the function? I am giving this definition of the function by discussing some examples. A function is like this box with two pipes. It gets input from this pipe and some operations takes place inside this box and gives output based on the operations occurred in this box. All that matters occurred inside only. The output is based on the operations occurred inside only. Let us understand an example. The operation it does inside is to multiply with to multiply every input with 2. Here I am giving 2 as input and it multiplies with 2 and giving output as 4. When I am supplying 9 as input, it multiplies with 2 and giving 18 as output. If I give minus 5 as input, it gives minus 10. If 10 is input and it multiplies with 2 and gives 20 as output. In the same manner, if I giving x as input, some operation takes inside the it multiplies with 2 and gives output 2x. So what the function here is 2x. The function occurred in this box is 2x. Multiplying any input with 2. Let us verify some relations. Either those relations are functions or not. Let us take first relation. R1 is a relation from A to B. A contains the elements 1, 2, 3 and B contains the elements A, B, C, D. Relation is a mapping from A to B. Now 1 is mapped to A and 1 is mapped to B. 2 is mapped to C. 3 is mapped to D. Let us verify, is it a function or not? I am directly saying it is not a function. Why? Because 1 is mapped to A and 1 is mapped to B. That means I am giving 1 as input, getting A and B are outputs. For one input, I am getting 2 outputs. So it is not a function. For one input, it should have only one output. For only one input, it have only one output. Okay. 2 here in this case for I am giving 2 as input, getting C as output. For 3 I am getting D as output. But in case of 1 I am getting 2 outputs. Is it not possible? So it is not the relation from A to B is not a function. Let us check some more relations. R2 relation to. Let R2 be a relation from A to B. Here I am taking a set A containing elements 1, 2, 3, 4, 5 and B contains A, B, C, D as elements. Here 1 is mapped to A, 2 is mapped to C and 3 is mapped to B, 4 is mapped to D. Here is no problem. I am giving one input and getting one output. For each input I am getting output. Only one output. For 2 as input I am getting C as output. For 3 I am getting B as output. For 4 I am getting D as output. But here I am giving 5 input 5 but here there is no output. In set B there is no output for 5. It is not in this case also it is not a function. This relation is not a function. Why? Because 5 is left in the first set. I am giving 5 as input but there is no output in the set B. So in such a case, it is not a function. Let us take one more relation R3 from A to B. A contains elements 1, 2, 3 and B contains elements A, B, C, D. Here 1 is mapped to A, 2 is mapped to B and 3 is mapped to C. Here for one input I am having only one output. For one it is having only one output. For 2 it is having only one output. For 3 also it is having one output. And also there are no elements left over here. That means no input is not having any mapping. That means all the elements in set A having outputs in set B. It is a function. The two cases failed here. So it is a function. Previously discussed two examples, that means two cases are failed. That means one input doesn't have two outputs or two more outputs. And any one of the elements in A does not having image. So here all elements in A having outputs. All inputs have outputs. Let us check one more relation R4. R4 is a relation from A to B. A to B. 1 is mapped to A, 2 is mapped to B and 3 is mapped to A. That means for input 1 it is having A as output. For input 2 it is having B as output. For 3 we have output A. That means all elements in the set A have output and any one of the input does not have two outputs. For one input there are only one output. So it is also a function. In brief, I am telling f is a function from A to B. When you say f is a function from A to B, let us take A is a set and B is a set. I am taking a function from A to B. A is mapped to B. Here A is not a single element. It is a representative of all the elements in this set. B is not a single element in B. It is also a representative of B. That means for every element in A, it is having output in B. Understood? For every element in A, having output in B. A unique output in B. This first set is called domain. The first set is called domain and the second set is called codomain. If f is a function from A to B, then the set A is called domain and set B is called codomain. Now come to our definition, function definition. For every A belongs to capital A, that means every element in A, there exists a unique means only one B belongs to capital B such that f of A is equal to B. That means if you apply, if you are taking A as input, some operations takes place. That is a function. Some operations takes place. It gives output B. This belongs to second set. This must be belongs to, the output must be belongs to second set B. Then we can say that f is called a function from A to B. It can be denoted as f is a function from A to B. F is a function from A to B. This symbol is known as for all. For all. This symbol means for all. This means there exist. There exist. And this symbol means such that. Such that. Understood clearly? For every element in A, that means for ప్రతి ఒక్క ఎలిమెంట్కి ఏలో ఉన్న ప్రతి ఒక్క ఎలిమెంట్కి దేర్ ఎగ్జిస్ట్ ఏ యూనిక్ బి బిలాంగ్స్ టు క్యాపిటల్ బి. యూనిక్ మీన్స్ ఏ సింగిల్ ఎలిమెంట్, సింగిల్ అవుట్కమ్, ఏ సింగిల్ ఎలిమెంట్ ఇన్ బి. దేర్ ఎగ్జిస్ట్ ఏ single element in B. That means for every element in A, there exists a unique element B such that f of A is equal to B. అంటే ఏలో ఉన్న ప్రతి ఒక్క ఎలిమెంట్కి కూడా బి అనే ఒక ఎలిమెంట్ మ్యాప్ చేయబడి ఉంటుంది. అది ఏ విధంగా మ్యాప్ చేయబడి ఉంటుంది? ఎఫ్ ఆఫ్ ఏ ఈజ్ ఈక్వల్ టు బి అయ్యే విధంగా మనకి మ్యాప్ చేయబడి ఉంటుంది. ఓకే, if it obeys this, then f is called a function. For every element, ప్రతి ఒక్క ఎలిమెంట్, ఏలో ఉన్న ప్రతి ఒక్క ఎలిమెంట్కి బిలో ఒక ఎలిమెంట్ ఉండాలి. ఎలాంటి ఎలిమెంట్, ఎలాగ ఉండాలి ఆ ఎలిమెంట్? ఎఫ్ ఆఫ్ ఏ ఈజ్ ఈక్వల్ టు బి అయ్యే విధంగా ఎలిమెంట్ ఉండాలి. దెన్ ఎఫ్ ఈజ్ కాల్డ్ ఏ ఫంక్షన్ ఫ్రమ్ ఏ టు బి. ఎఫ్ ఈజ్ కాల్డ్ ఏ ఫంక్షన్ ఫ్రమ్ ఏ టు బి. దట్ మీన్స్ by observing all the cases, all the relations, what we can conclude, every function is a relation. Every function is a relation, but every relation need not be a function. Let us see this example. This is a relation and also a function. That means a function is also a relation. Here also this is a function and also a relation, but here it is a relation but not a function. So what we conclude here, every function is a relation but every relation need not be a function. That means all functions are relations. All functions are relations. This means all functions are relations, but all relations need not be a function. All relations need not be functions. Need not be functions. Now function definition. Once again I will tell you. For all A belongs to capital A, there exists a unique B belongs to capital B. Unique means ఒకే ఒక్కటి, ఒకే ఒక్క బి ఎగ్జిస్ట్ అవుతుంది. ఏ విధంగా ఎగ్జిస్ట్ అవుతుంది? ఎఫ్ ఆఫ్ ఏ ఈజ్ ఈక్వల్ టు బి అయ్యే విధంగా ఎగ్జిస్ట్ అవుతుంది. ఫర్ ఆల్ ఏ బిలాంగ్స్ టు క్యాపిటల్ ఏ, దేర్ ఎగ్జిస్ట్ ఏ యూనిక్ బి బిలాంగ్స్ టు క్యాపిటల్ బి సచ్ దట్ ఎఫ్ ఆఫ్ ఏ ఈజ్ ఈక్వల్ టు బి. దెన్ ఎఫ్ ఈజ్ కాల్డ్ ఏ ఫంక్షన్ ఫ్రమ్ ఏ టు బి. This first set A is called domain and the second set B is called codomain. That here A is called pre-image of B. Image of A. B is called image of A. Image of A. For every element there should be an image in B. This means for every element in A there is a image in B. This is called, this B is called what? Image of A. And A is called pre-image of B. This A is called pre-image of B. Pre-image of B. That means, listen carefully. ఏ అనే సెట్లో ఉన్న ఎలిమెంట్స్ని ప్రీ ఇమేజెస్ అంటాం. వేటికి? బిలో ఉన్న ఎలిమెంట్స్. అలాగే బిలో ఉన్న ఎలిమెంట్స్ని ఏలో ఉన్న ఎలిమెంట్స్ యొక్క ఇమేజెస్ అంటాం. ఓకే, ఇఫ్ ఎనీ ఎలిమెంట్ ఈజ్ మ్యాప్డ్ టు an element in B, then the such case A is called pre-image of B, B is called image of A. Okay, this is the definition of a function. Thank you.